Whatever, I'll just cut all that out. Okay. So, welcome back, everybody. Hope we all had a nice summer. Today we're going to be going over binary counting and other systems rather than just base 10. We're getting right back into the things with the start of the new school year. So, counting in base 10, let's start off with that. That's what we're all used to with the 0, 1, 2, 3, 4, and so on until you reach 9. And then what do? You put a 1 and a 0. So you have 1, 10, and 0 ones. That's base 10. That's what we're all used to counting in. Now if we say wanted to count in what computers count in, which is binary, you have either on or off, or a 1 and a 0. You have 2 digits rather than 10. 0 through 9 as opposed to 0 through 1. So, I guess I should reverse these. 0, 1. There we go. So let's begin with writing the number, well, number 1 should be pretty self-explanatory. It's just a 1. So, how do we go from there since all we have is 0 and 1 to work with? Well, it's the same thing with these. You only have 0 through 9 to work with, but once you get past 9, you can keep going. You just slide over to the next place. Same thing with this. You just slide over to the next place. But instead of being instead of 10, that is the wrong, there we go. Instead of 10 being 10, 10 is now 1, 0 with a 1 in the 2's slot, or in the 2 to the 1st slot, and a 0 in the 2 to the 0th slot. So instead of working off of powers of 10, we work off of powers of 2 in binary. So that means it goes, instead of, for base 10, it goes 10 to the 0, 10 to the 1st, 10 to the 2nd, and so on. So to write like 121, you have 1, you have 1 100, which is 10, which is a 10 to the 2. What did I say? 121? Yeah. So you have 1 10 to the 2 and 2 10 to the 1st, or just 10s, and then 1 10 to the 0th. 121. Pretty easy. It's just numbers, right? It's what we're all used to. But to write in binary or base 2, what you have to do is, instead of going by powers of 10, you go by powers of 2. So you have 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. I'll go up all the way to 6, 2 to the 5th, and 2 to the 6th. Now each of these correspond to a number. 2 to the 0 is a 1, 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. Oops. 64. So, using these, how would we write a 4? It would end up being, you would need 1 2 to the 2nd, so 1 4, 0 2s, and 0 1s. So that means it would be 1 0 0. That's 4 in binary. If you wanted to write 6, which is not a power of 2, you just do what you did for base 10 and combine them. So you combine what's the highest you can go and then subtract from there. So the highest you can go with a 6 is a 4. So that means you need a 1. And then what's left after 4, or after you subtract 4 from 6, is 2. So then you need 1, 2. And then what's 2 minus 2? 0. So you don't need any 1s. So that's 6 in binary. Equals 4 in binary equals 6 in binary. So let's say you want to write something a little bit larger, like 75. 75, I'll get a new color. 75 in binary would be, take the largest power of 2 you can get, which is 64. So that means you'd need a 164. So then what's 75 minus 64 is 11. And what's the highest you can get from that is an 8. So that means you skip 30 seconds, or you skip 32, and you skip 16. So 0, 0. That's a big 0. Nope. 0. And then you need 1 8. So an 8. And then 11 minus 8 is 3. So out of a 3, can't get a 4. So 0. But you can get a 2. So 1. And you can also, with that, 3 minus 2 is 1. So then you need a 1. Boom. 75 in binary is 1 0 0 1 0 1 1. That's pretty much counting in binary all covered. So I'll leave that little green thing up there so it's easier to remember. So how do we add and subtract? Adding and subtracting, it's the same as normal. Well, pretty much the same as normal. So what you do, let's say you want to add 1 0 1 1 to 0 0 1 1. Now what these two numbers are, this is equal to 1 1 and 1 2, so that's equal to a 3. This is 1 1 1 2, no 4s, and an 8, so that's equal to 11. So 11 plus 3, we have to get 14, which 14, what's the highest you can get out of that, is an 8. So that means it is 1 8, and then 14 minus 8, 6. So then we can get a 4 out of that. 4, 6 minus 4 is 2. So we can get a 2, and then we have nothing left over. So like that. So it's essentially the same. You can recognize a pattern here with, like, if you add a 9 plus an 8. That's a terrible example. Oops. If you add a, I don't know, like a 21 to a, 22 to a 29. What you end up with is 2 plus 9 is 11. So you write the 1 down there, and then you carry the 1 up, because you had 11 from that. And then you add all those together, and then you get a 51. That's easy. That's just like first grade math. So it's the same principle here. You have a 1 and a 1, which equals a 2. So what you do is you take your 2, or 1 0, carry the 0 down here, and write the 1 up here. And then what you do here is you have 3 2s. 1 1 1. That's 3 2s. So what you do, that equals 6. So 6 doesn't, you can't write a 3 down here for that. So what you'd have to do is carry 2 of those 2's over like we did with the 1's and make a 4 over here and then leave a 2 down here. So now we have 0 4's plus 0 4's plus 1 4 is 4, and then we have our 8 over here. So it's the same principle as carrying numbers over, except you carry them over a lot sooner. Instead of every 10, you carry them over every 2. Hopefully that makes sense. And then subtraction, it's pretty much the same. Let's say 1 0, we'll do the same numbers. Minus 0 0 1 1. So that's 11 minus 11 minus 3. Should be 8. What you can see here, this is going to be a lot easier than addition. You can just see which ones will cancel out. So you'll have a 1 1. Those are both gone. Those are both gone. Those cancel out, and then there's nothing to subtract here, so it's just 1 0 0 0, which is 8 in binary. So hopefully adding and subtracting in binary makes sense, and hopefully binary counting also makes sense as well. Yeah, that's it for today. I don't even remember how I used to do the outro on these. Hope everybody has a good day. Happy studying, and thanks for stopping by.